Hi everyone, in this video I will be going over the problem Roads in Chefland from the May Cook-Off 2020 CodeChef contest. So the problem statement is that there are n cities numbered 1 through n, and we want to build roads between these cities such that all cities are connected. And so for a pair of cities I and j, the cost of building a road between those two cities is equal to the bitwise AND operation performed on I and j. And so we're given that each road must have a positive cost. So what this means is that let's say we had city 1 and city 2. So city 1 can be represented by 0, 0, 0, 1, and city 2 can be represented by 0, 0, 1, 0 as our binary representations. So if we were to perform the bitwise AND operation on this, we would get a total value of 0. So then in this case, the cost of building a road between cities 1 and 2 is 0, which means that we cannot build a road because again, the cost must be positive. Okay, so basically we want to find the minimum cost of building roads in this required way. And if it's impossible to do so, we would return -1. So let's look at a few test cases so we can better understand this problem. So let's say we had an input of 3, which means that there are 3 cities numbered from 1 to 3. And again, we want to find a way to connect the cities such that we minimize the cost. So then let's look at each pair of cities and see what it would cost to build a road between every pair. So again, if we have cities 1 and 2, we already determined that this is not possible because if we perform the bitwise AND operation, we would get 0, 0, 0, 0. So we would get a cost of 0, basically. And then let's look at cities 2 and 3 now. Now this time, if we perform the bitwise AND operation, we get 0, 0, 1, 0. And so now here, the cost is 2, because the 1 over here represents 2. Now let's look at our last pair of possible cities, which is cities 1 and city 3. So in this case, if we were to perform the bitwise AND operation, we would get 0, 0, 0, 1. So then this would be a cost of 1. And so the answer to this input of 3 would be 3, because we would just add these two costs. And we notice that by building roads between cities 1 and 3 and by cities 2 and 3, we ultimately connect all cities that are given. So we can notice that we always want to connect the cities that give us a minimum cost. And one important observation is that this occurs whenever we connect cities to the number that is a binary representation of the rightmost one in that city. So for example, here we have city 6. And so the rightmost one in this binary representation is over here. And this one represents the value of 2. So in this case, the most optimal city to connect city 6 to would be city 2. Because we notice that city's 2 binary representation is 0, 0, 1, 0. So then if we were to perform the bitwise AND operation on this, then we would get the value of 2, which is the minimum cost we can get if we were to connect city 6 to any other city. And so same thing, let's look at this example with city 12. So city 12 can be represented in binary with 1, 1, 0, 0. And so again, the rightmost one in this case occurs over here. And this value is represented by 2 to the power of 2, so 4. And so if we connect city 12 to city 4, then again we get a cost of 4 if we were to perform the bitwise AND operation, which is the minimum cost we can get if we were to connect city 12 to any other city. Okay, so here I formed different groups representing the different ways we can form binary representations. So group 1 represents all of the numbers where the rightmost one is at position 1 from the right. So here we have a few examples, and we can see that in each of these examples, the rightmost one is at the very last position. So it's at the position that represents 2 to the power of 0, or 1. So what that means is that for all numbers with this characteristic, where the rightmost one is at position 1 from the right, then we can connect all of these cities to city 1. And so the cost would be 1. Because again, if we connect it to city 1 and we perform the bitwise AND operation, then we would get 1, which is again the minimum cost we can get. And so same thing with group 2. So in group 2, the rightmost one is at position 2 from the right. So from the right, it's at the second position. And so this represents the value 2 to the power of 1, or 2. And so what that means is that any city of this form, any city in group 2, can be connected to city 2. Because again, city 2 would be 0, 0, 1, 0. And so then if we perform the bitwise AND operation, we would get the value of 2. And so we can actually generalize this. So for group X, where the rightmost one is at position X from the right, then the cost is 2 to the power of X minus 1. Okay, so let's go back to the original problem. So again, we're given a number n, which represents the number of cities. And so we want to find the cost of connecting all of these cities together with roads. And so what we essentially need to find now is we need to find what groups the numbers from 1 to n are in. Because if we find the number of numbers in group 1 and the number of numbers in group 2 and so on, we can simply multiply the number of numbers in each group by the cost that is associated with each group. So for example, in group 1, if we had 10 numbers, so 10 cities that we would want to connect to city 1, then we can just multiply 10 by 1. So get the total cost of connecting cities of group 1 to city 1. And so same thing with group 2 and all the way up to group X, we would just multiply the number of cities in group X by the cost, which in this case would be 2 to the power of X minus 1. So now we just need to figure out what this is. Okay, so to find the number of cities in each group, let's start by listing out the numbers that would be associated in each group. And let's see if we can find some sort of pattern. So for group 1, the rightmost one is at the first position from the right. And so group 1 would actually include all of the odd numbers. So it would be 1, 3, 5, 7, 9, 11, etc. And then for group 2, the numbers in group 2 would be 2, 6, 10, 14, 18, etc. And if we figure out what the numbers in group 3 are, we would get 4, 12, 20, 28, etc. And so we can figure out these numbers just by calculating them ourselves by looking at the different binary representations that fulfill this condition of the rightmost one being at position X from the right. And so again, the cost associated with each group would be 1, 2, and 4. Now, one interesting thing to notice is that each number in the group is essentially the cost times 3. This would be the cost times 1. This would be the cost times 5. And this continues in the other groups. So for example, in group 3, the first number is the cost times 1. The second number is the cost times 3, and so on. So we notice that each of the values in the group are essentially the odd multiples of the cost associated with that group. And so based on this, we can actually come up with a formula for calculating the number of numbers in each group. But before we do that, one important thing to notice is that within each groups, the very first number is 1, 2, and 4. And so if you think about it, these numbers represent the cities we want to connect each group number to. So what that means is that in group 1, all the other remaining numbers, so 3, 5, 7, 9, 11, all of those cities would be connected to 1. And so same thing with group 2, all of the other cities except for 2, so 6, 10, 14, 18, are meant to be connected with city 2. And so because of that, when we're considering the number of numbers in each group, we are not going to consider 1, 2, and 4. So for now, let's just calculate all the remaining numbers. So the formula for this is actually n minus the cost divided by 2 times the cost. And let me explain why. Now the reason why is because remember that in each group, we're taking all of the odd multiples of the cost. So let's say we had x numbers. Then to find the number of multiples of costs that exist from 1 to x, we would simply divide it by cost. However, we don't want to find just every single multiple. We only want to find the odd multiples, which is why we divide it by 2. And so now this is a formula that calculates the number of odd multiples from 1 to x. However, as I already mentioned before, we want to disinclude the first numbers of each group. So we want to disinclude 1, 2, and 4. So in order to account for this, we would do x minus cost. And the reason why we subtract cost is because the first number of each group is the cost. So instead of finding all the multiples from 1 to x, we want to find all of the multiples from cost to x, which is why we subtract cost from x. And so this gives us our overall formula for the number of numbers in each group. And so what we want to do then is we want to multiply that by the cost of each group. Okay, so we now have our formula. But then one thing we haven't accounted for are the first numbers in each group. So cities 1, 2, 4, 8, 16, etc. So what we want to do is we want to find what city is the most optimal to connect to each of these first group values. So for 1 doesn't need to be connected to anything because 1 will be our starting node, which we connect everything to. However, if we look at cities 2 and cities 4, we need to somehow connect them to another city. So what we can notice is that, for example, for city 2, the binary representation for it would be 0, 0, 1, 0. And so again, we want to minimize its cost. So we notice that if we just take 2 plus 1, we would get 0, 0, 1, 1. And if we do the bitwise AND operation on this, we would get 2 as our cost. Now let's look at the first element in group 3, which is 4. So again, 4 would be written as 0, 1, 0, 0 in binary representation. And so again, let's take the number 4 plus 1, which is 5. So that would be represented with 0, 1, 0, 1. And so here, if we perform the AND bitwise operation, we get a cost of 4. So here we can notice that it's optimal for numbers that are powers of 2 to perform the AND bitwise operation with the power of 2 plus 1. And the cost we get for performing these operations is the same cost associated with each group. So the cost for connecting city 2 to city 3 is 2. The cost for connecting city 4 with city 5 is 4. And that occurs so on with the other groups as well. And so because of this, to this formula we have already, we can just add the cost. And so this one formula over here would account for basically every single number in each of the groups. So now that we have this formula, let's actually try coding this problem. Okay, so I'm going to be going over the code now. So I created an integer t, which represents the number of test cases. I inputted it, and so I'm doing a while loop while t minus minus. And so within this while loop, I have a long n, and I'm inputting n. And again, n represents the number of cities. And so the first thing we want to do is we want to check if the number is a power of 2. And the reason why is because, as I already explained, a number that is a power of 2 needs to be connected to a city that is the power of 2 plus 1. So for example, if we have city 4, that will be represented by 0, 1, 0, 0. It needs to be connected to city 5, which is 0, 1, 0, 1. And it cannot be connected to a city that is below it in terms of the number. So what this means is that if n is a power of 2, then already we know that we cannot connect all cities because we will not be able to connect that last power of 2. So in that case, we would see out -1 and we would end the program right there. And so one trick for determining if a number is a power of 2 would just be do n and then do the AND bitwise operation and do n minus 1. And then just check if that's equal to 0. And so that checks if n is a power of 2, and then if it is, we would see out -1 end line. And so the reason, let me just quickly explain the logic behind this. So if we have a power of 2, then it's going to be represented in this format, where we have a 1, and then everything after that would just be zeros. And so the power of 2 minus 1 would look something like this. And so notice how all of the ones basically correspond to all of the zeros after this original one. And so what this does is that it guarantees that if we were to perform the bitwise operation between these two numbers, we will get a value of 0. Okay, so after we have that established, let's go on to the else statement. And so let me create a variable called cost. And so I'm going to be calculating group 1 separately from the rest of the groups. And so for group 1 contains basically all of the odd cities. So let me just create a variable called odd counter. And so the number of odd cities would just be n plus 1 divided by 2. And so we would add that to the cost, and we would subtract 1. And so the reason why we're adding it to the cost is because, again, the number of odd cities is all of the values in group 1, and all the values in group 1 has a cost of 1, so we add it. The reason why we subtract 1 is because one of the odd cities is 1. However, as we already mentioned, the city 1 does not have any cost associated with it, which is why we subtract 1 for the city 1. Okay, so now that we've figured out group 1, let's just use the formula we determined for the rest of the groups. So we're going to create a variable called current cost, and we're going to initialize it to 2, because 2 is the next cost after 1. And so basically we're going to have a while loop, so while current cost is less than n. So this ensures we go through all of the groups. This is just a formula we already did, so let me just write that out. And then we want to update current cost. So the next cost for the next group would just be the current cost times 2. So we can just do a left shift. And then at the end, we would just see out cost end line. Thank you for watching, and please don't forget to like, subscribe, and comment if you enjoyed this video.